Atharv?
Hey, hi Praveen.
Hi. So you also feeling sleepy?
नहीं कर सकता हूँ मैं क्लास.
Okay.
Yeah. लास्ट लेक्चर नहीं अपलोड हुआ ना?
Yes, not yet.
मैं देख नहीं पाया क्योंकि
ओके मैं कोई नहीं हमने डीपी के प्रॉब्लम सॉल्व किए थे. दिस क्लास आल्सो विल डू डीपी प्रॉब्लम्स ओनली.
ओके तो समझ जाएगा राइट?
हाँ there was no special theory. It was just few DP questions. If you want, I can go through the question right now. Like what were the questions? My product solution. एक मिनट. So do you see the editor? Do you see the editor?
Yes, I can see.
Okay. Okay, so last class we did some questions on DP only. And today also we'll do more questions on DP. Why so much of focus on DP? Because it's tough hota hai, or you people will, after doing 6-7 questions here, you'll be able to at least think how to even approach a DP problem. Most of it is similar thing again. Find the recursion. This is the most important. If you're able to find the recursion, then you have solved the problem almost half. Then the next part of the problem is think about the storing the value of the sub problem which you're going to solve. Since it's a recursion, we will be what does it mean? Every recursion it calls up recursively the same method for a sub problem. So that's that output of sub problem you don't have to return. If it was normal recursion, we just return the value. If it is a DP, what we do, we store and then return. And where do we store that? Store you have to think about. How does that story look like? And then finally about your base condition in the recursion will become the initializing the storage with some values is the base condition of our DP. So there are 3 things we have to do. So example I took was example. Let's come to. And then one more thing I was talking about is top down and bottom up approach. Both of them. What was the difference between these two? So when we are solving our DP problem, the recursion, either you can solve 2 ways. One is top-down approach or bottom-up. Not necessarily every time we'll do everything, but there might be 2 ways to solve that. Either you start from base condition, बिल्कुल base से start किया, and then you keep on. So for example, you have to find the solution for n or an input of size n. You do it for an input of size 0, input of size 1, input of size 2, and iteratively you reach that n. That is a bottom up approach. You start from the basic condition and then you just iterate a loop and solve for all the values less than n. This is called bottom up approach. And in the top down, this is the top down approach is almost similar to your recursive call only. It's just that you store that value somewhere before returning. So these are 2 things different between. These are 2 things, the 2 ways to solve a DP problem. So mostly I've talked till now was one dimensional DP. How do you store a solution? It's an array of what we do is we create an array and we store with some, we initialize with some native value or some random value, which means we haven't yet calculated. Okay. And evidently till now it has been a one dimensional array. But now comes the 2-dimensional DP. What is this is term given by me only, it's not written anywhere. So what 2-dimensional DP means, the problem is not just based on one input, but it's based on 2 inputs, so n and m, both of them. In that case, it is still a recursive call. We still make a recursive call, solve method for m, n, but we have two. Either we change our m or we change our n. Either we decrease our m or we decrease our n in the sub problem, or we decrease both. That's what recursive call we have to make. We still have to make the recursive call, but we'll change our m, we'll change our n, or we change both. That is the requirement of the problem. In that case, our storage will be two-dimensional array. So we have to store the value for all the subproblems, and subproblem is not linear subproblem. It's like all the subproblems depend on both m and n, and hence our storage will be two-dimensional. Okay, simple to digest. What is Now we do a question on knapsack. One of the most popular question on what we do is a knapsack. Knapsack problem. What is that? It says we have some objects. All the objects have some value and also some weight. Okay, so I try to make an analogy with a thief stealing something from a bank. Some objects from there are golds, there are silver, there are some all the objects, and all of them have some value. Okay, some rupees, but all of them have some weight as well, and he can only carry 50 kg on his back to run. So he cannot carry more than capital W. So what are the objects he should take so that he can get maximum value, but he does not exceed the weight 50. So that what are the possible object he should take in his bucket or whatever. So this is a DP problem, and this is a two-dimensional DP problem. So first, let's approach. We'll try to. So everyone has joined. Let me see. Okay, so Vasant doesn't seem to be joining. So we'll start anyways. So I was just doing knapsack again. I will go ahead with more questions. Okay. So I'll just cover knapsack once again, and then we go ahead. So knapsack was this. We have the values, we have the weights, and now we have to return the maximum value which can be generated with a maximum weight limit of 50. We cannot have more than 50. So this was a recursive solution. So if we start from the last object and we check if the weight of the last object is more than what we can carry, I just skip that. I don't want that anymore. That object, whatever the value is, I don't care. I can't even carry what do I to take. So this is a recursive call. Just for the same weight W, I still have 50 weight limit. I call it recursively for the same value array. Sorry, this is the array. This is not capital W. This is the W array, weight array, and this is value array. They're using weight array and value array. It's confusing. This is the maximum weight in.
Yeah, maximum weight, value array, and a weight array.
Yeah, value array, weight array, and the last index
number of objects.
Yes, number of objects. So now this is recursive of the same weight, but and the same value array and the same weight array, but one size decreased. So this is simple to understand. Now this is there are two things we can do. If the weight is less, if the last weight is less than the capital weight, either we take that or we do not take that. So this is either we consider that to. So this is like I want that object. So now I can take anything less than that only. So weight minus the last weight of the last object, and the same value array, same weight array, and n minus 1 did. Or the other way would be I skip that object. So both of them can lead to optimal solution. I don't know which one. So what we do is we try to calculate both of them recursively, and then check whichever returns me maximum. I'll return that. Okay?
Yeah.
This is what recursion is, and that's the first step for our DP. We have the recursion. Now comes this. We want to convert this recursive function into a DP. So we just first initialize our storage. So we have to think about the storage. So initialization comes later, but storage, what to store. Now, so if we see this problem, it's not a one-dimensional DP, it's a two-dimensional DP. We have two. So either we decrease the weight, or we have to find for all the weights and all the objects. So we have n plus 1 objects, and we have W weights. So we are trying to solve. If you took this, looks like a little bit brute force approach. What we're doing is we try for all the weights: 0 weight, 1 weight, 2 weight, and till W weight. So we try for all the weights and try to find the minimum try to find the maximum value which we can generate for all those weights, and by doing that we just keep on incrementing and we reach our W. So we have to do for all the W. Similarly, we have for each W we have to do for all the objects, for 0 object, for 1 object, 2 object. So this is a storage which stores what? It stores every index stores the maximum value you can generate using the first I objects with a maximum weight limit of J. This is what is stored in every cell of the 2D matrix, every cell of the 2D array. At I, this is what means maximum value you can generate. So this is like so many sub problems. We just have to find for N and W, and we have found for so many others. If someone needs, someone take it away, but we don't care. So just to find for N, W, we have to find for all of them. And yeah, it took a lot of time, but it's still much better than this algorithm, which is equation. This was exponential, and this will be is this going to be N into W. That's the benefit of, even though we are doing for all of them. यहाँ पे एक calculate करने में हमें exponential time लग गया था, which was 2 to the power n, I guess, and this will be just n into W, not just, but it is n into W. So this is the storage we are talking about. So second step, what storage will be. Third is initializing. So this we have to do some initialization of the storage first of all. So I have just given you this. These are the objects 0 to n, and these are the weights we have to do for all the objects and all the weights. So this is the initialization part. If I equal to 0 or j equal to 0, if either of them is 0, then storage of ij equal to 0. What this initialization means? If I'm not taking any object, or if I'm not doing for any weight, in both the cases, my answer is 0. I cannot generate any value if I'm not allowed to use it 0. If I'm not allowed to use 0 object, or if I'm allowed to build only 0 weight. In both the cases, I have no option. So this is 0. This is initialized by 0. So once and this is initialized properly. Now, actually, it's not getting initialized before we start solving. We are initializing it within the loop only. Or we could have done this initialization before only. Both the things work. This is why this is not a problem, because anyways, what we're doing is we are going to use to calculate our ij. To calculate our ij, we are going to use anything smaller. I'm talking smallest problem is either I is less than I mean this index is less than I, or this index is less than equal to j. If either of them is less than your previous, this is a problem. And whenever we reach ij, we will for sure we would have calculated for all the values less than I and less than j. So we are going to use that. So that's what, this is not a problem. They has to initialize this inside the loop, because whenever we reach a condition where to solve for ij, we would have already have calculated for this I0 and J0. So yeah, अंदर भी initialize कर सकते हैं randomly. I mean, not necessary to do it before the loop. Anyways, so now comes the main part. I don't want to discuss base part first. I want to come and discuss the main part first. So what is this what that recursion has reduced to? So if so we are doing for I and j, where I is the index for the I minus 1 is less than j. J is the current weight, and I is the current object. Okay. So if I minus 1 is the current object, index of the current object. So if the weight of the I minus 1 is the object, the current object we are going to consider, if that weight is more than j, if that weight is more than your current last object, so we don't have to consider. So this is equal to storage will equal to one less object. I don't want that object. So storage of I minus 1. Okay?
Right.
Yeah. Now this is, we don't want that. And last is again maximum of the two value which we can do. One is the same. I don't want that object I minus 1, and this is wrong. Yes. Storage of I minus 1 j. So this is one way. I don't want that object. So this is I minus 1 and with the same j value, or I want that object which is the value of that object, value of I minus 1 plus reduced weight and decreased index. So reduced weight is j minus weight of I minus 1, and decreased index is I minus 1. Simple, easy. Recursion देख करके समझ आ गया? ठीक है? I'll move ahead with the next question. So last class में did we do anything else after that? Did we do this, Subhadeep?
I have seen into the chat.
Okay, did we do even the next question, which was largest sum contiguous array? Did we do this? No, I don't do this. So I think I think this was your assignment. Did you people try?
I have sent it into the chat.
You have sent in the chat? Yes, you sent. I remember you sent in the chat. Yes, yes. So let's discuss that now. Chat. Where is? Yes, I'll copy that and paste here. Yes. So you said you again. So the question is longest common subsequence. So we have this string 1 and 2, and there are subsequences. So what is subsequence? Any in this sequence from left to right, just pick any character and combine that, and that becomes a subsequence of this string. So A, B, H is a subsequence. B, C, G is a subsequence. Just same. I mean, slightly different substring is a subsequence. We don't have to necessarily take all the consecutive characters. Okay, so that's a subsequence. So question is for these two objects, for these two strings, which are the two subsequent which is same and has the maximum length, largest common subsequence. So in this we can, if we see A, D, and H, and A, D, and H are two subsequences similar in both, and they are the length is 3, and then we cannot get anything bigger than that. So yes, that's what we have to calculate. And I had given a very the recursive solution, the first part, recursive solution. And then I had asked you to do the DP part. So let's again go through the recursive part, which is this. So what happens? Either the last index of both the string is same. Okay, in that case, if the string 1 ka last index and string 2 ka last index m-1 index is same, then we just return, because they're same, they will be part of the subsequence which you're trying to find. Whatever subsequence there is, it will for sure contain the last index because they're same. So so the recursive solution will be 1 for that equal part, and then call recursively for decreased index of both of them, string 1 and string 2. So one size decrease for string 1, one size decrease for string 2. Now, if they're not equal, then in that case, you can have two choices. One, that you skip, that you don't even consider the last index of string 1, or second is if you don't even consider the last character of string 2. Both of them can give you proper solution. We don't know which, so we try to calculate both of them. LCS, the longest common subsequence for string 1 and string 2, with string 1's index size reduced by 1 and string 2 size reduced by 1. Both of them can give us a solution. I don't know which, so I have to call recursively. Okay, so this is again a 2 to the power n exponential algorithm, because we are calling 2 recursively and we are decreasing by 1 by 1. So this is 2 to the power n, this is also 2 to the power n, and we don't know. I mean, yeah, that's a very exponential bad recursion, so we have to improve upon this. So this is a solution given by Subhadeep. Let's check this. Okay, so first thing is we have done the recursion. Now first thing is after that is to think about the storage. So what he has done is, so we want to do this for all the for the string of all size and of string 1 and string 2. This is what recursive storage he has thought about. So initialize an array with n plus of size n plus 1 and m plus 1. So we will do for all size 0, size 1, size 2, and size n. We have to do for all the sizes. And at then what we want is storage of n and storage of m. Is this correct, Subhadeep? What we want to calculate is storage of n and m. So either we can start from top down or bottom up, whatever. But what we want to return is this. What we want to calculate. So if this is calculated, we'll be happy. So how do we? The way you have tried is first initialize for I equal to 0 to m, j equal to 0 to m, and I equal Okay, so you have for I less than n, j less than m. If either of them equal to 0, just make it 0. So what does that mean? That if either of the string is of length 0, we will not be able to find any common substitute, and the length of the common substitute will be 0. So it's very simple initialization. Sometimes this part might be a little bit tricky, but so this is the okay. So this is the initialization part, the basic condition. Okay, and then comes the main thing. So if last two, the same thing condition, if the last character of the string 1 and last character of string 2 is same, then our answer would be the sub problem storage of I minus 1 and j minus 1 plus 1. So if you see this I and j, whenever this is getting calculated, this would have already been calculated. Why? Because that's the way we are growing our indexes I and j. So we are going from 0 to n, 0 to m. Whenever we reach I minus 1, either I minus 1 or j minus 1 or both minus 1, all three would have been calculated. But we only care about one of them right now. We only care about I minus 1, j minus 1, and hence this will be the solution for ij. That if they are equal, if they're not equal, then one of them reduced and other one reduced size. And this, I don't know which one will give a solution. We did a maximum of either of them. Okay, and again, this is not a recursive call, so it won't be a problem. This would have just a single index fetching a value from the array. This is also fetching a value from the array, simple one value. So, and at the end, when our loop is complete, when we're done for all 0 to n and 0 to m, we'll just return the storage of n and m. Is that okay? Simple.
Yeah.
अच्छा समझ में आया?
Complexity.
थोड़ा
Okay.
Complexity. Yes. Subhadeep, you tell me, what is the complexity?
Order of n, correct? Because we have there is two groups, but if we are storing, that's why it will be order of n. Correct?
Order of n.
Order of n square. Order of
n
n
square.
Order of n.
Order of n, you are saying. I don't understand. How do you see this order of n?
Order of, we are storing the
This?
no, order of n square.
It will be n cross m, right? Order of n cross m.
N cross m.
n into m, simple. ये तो बहुत ही simple है. इसमें क्या दिक्कत हो रही है? We are doing for all the n, we are doing for all the m. We are just doing some constant operation for this full loop, and it's like two loops अंदर में कुछ print a string. That kind of thing is. अब वो print हम कितनी बार कर रहे हैं? n into m times, simple तो है. Okay? ठीक है. Let's move to the next question. It is largest sum contiguous subarray. Largest sum contiguous subarray. What does it mean? We have so many contiguous array. This is -2, -3, or -2, -3, -4. All these are some subcontiguous array. This is also a subcontiguous array. Okay, like any array from any index to any index from 0 to n, we have values I and j. We have I and j. So all the arrays from a of I2 to a of j, all these will be called a contiguous sub array. So the problem is, so there's so many contiguous array. Which one has the maximum sum? We have to find that sub array, or you just have to find the sum. Just find the sum of that sub contiguous array. समझ में आ गया question? Is the question clear to everyone?
Yes.
Yes. Size defined नहीं होगा, correct? Like array में like 3 elements or 4 elements.
It will be depending. So any size you have to. So there is an array of size n, integer array of size n. ठीक है? So start thinking the solution for this, and then we'll discuss in something like for 5 minutes. But try to write recursion, try to think about the storage, and try to think about the initialization of storage, the base conditions. Okay?
Alright, the array should be contiguous. फोर से 5 तक होगा कॉन्टिग्यूअस, नॉट जस्ट सम,
4 से 5 तक।
क्योंकि दोनों पॉजिटिव और बीच में अगर नेगेटिव भी रहा तो बाकी सब केस में से ज़्यादा 7 आ रहा है 4 to 5।
ओके,
इसको क्या रिकर्सन से सॉल्व करना है?
कितना टाइम लगेगा? चलेगा नहीं रहेगा तो लॉक करना था।
आप कहाँ रहोगे? आप कहाँ रहोगे? नीचे रहोगे?
हाँ मैं तो नीचे।
मैं बता दूंगा 2-3 घंटे लगेगा।
कॉफी तो चाहिए। चाहिए बिस्किट।
अरे तो कॉफी भी दे दो।
कॉफी वो आपके साथ है।
Yes, Suri, you are correct. So now find a solution for this.
ये रिकर्सन से करना पड़ेगा, सब प्रॉब्लम ढूंढना पड़ेगा।
Yes, search.
एक ही इनपुट है तो 2D मैट्रिक्स भी यूज नहीं होगा।
What? Come again?
एक ही इनपुट है तो 2D मैट्रिक्स इज नॉट रिक्वायर्ड राइट नाउ।
एक ही इनपुट है। इनपुट तो
एक ही है।
कंटिन्यूअस
No point है।
So it's not the input which decides. Actually, एक ही input है तो it's not that the statement is not correct. The sub problem you are trying to think, the sub problem is what decides how will you have to is it 1 DDP or 2 DDP. So what is your sub problem?
Sub problem will be sum of two, like -2 or -3. दोनों का सम कैलकुलेट करते रहेंगे।
So you have to calculate the largest sum contiguous sub array of an array from 0 to n. So what are sub problems? Sub problems can be break that array into two small array, or break that into 3 small array, or or just break into one small size, or just break into two small size, something like that. So what is the break you are going to make? Like what is the break that you're going to do?
Small size and bigger one, maybe. We have to check each and every time. We have to check one at a time and store those values.
One at a time and store the what is the what is the one at a time doing?
So let's say -2,
Mm-hmm.
then we will add -3, and we have to store that as a like additional variable sum or something. And we have to
Okay.
keep doing that. Something like that. I'm not sure.
Mm-hmm. So recursion, first think about the recursion a little bit. You have to solve for an array of size n, or other way to say it, one more statement can be, you have to solve for an array from 0 to n. You have to solve for an array uh, which is ending at index n. There are multiple ways to say the same problem, and why I'm repeating this, because this is what will help you in finding your sub problem as well. So first line I said was, you have to solve for an array of size n. Okay, so can we break into a can the subproblem be, we have to solve for an array of size n by 2 and then do for all n by 2 and then use that to calculate our for n? Can we do that? Or the other statement can be, we have to solve for array of size n. Can we solve for a size of n minus 1 and use that? Or other statement can be, we have to solve for array n, so can we break it into a smaller array of size n minus 2 and then use that? So these are few things when we consider a problem like we have to solve for an array of size n. If you consider a problem like we have to solve an array from 0 to n, if we have to solve for an array from 0 to n, so can we try for all the array ranging from 0 to I to j and use all of them to calculate my 0 to n? So I'll try for all combinations of ij and then use that. So if you talk about the problem that way, so how do you talk? Like if you have to solve the problem for an array of size 0 to n. The third way we can think about the problem is, we have to solve for an array which is ending at the index n. So what if I solve for an array which is ending at index n minus 1? Can I use that to to find the following combination? Yes. So all these ways will help you in thinking of sub problem. First, define your problem correctly. I have written a very generic word, largest sum contiguous sub-array problem, but you will have to think of the problem first. So what is the problem you're trying to solve based on your input? So define your input, define the input parameters, and then just write this line. We have to solve for an input of size n, for an input from 0 to n, for an input with ending at n. Just write this line and then think about the subproblem.
कर सकते हैं, डिवाइड करके एक बार लेफ्ट साइड के लिए चेक कर सकते हैं और मिडिल से राइट साइड तक चेक कर सकते हैं.
So what is the problem you define? Can you define the problem?
Sorry?
Can you, what is the problem statement you have defined? So one liner statement. Solve. What is the way I gave you so many options? Which one you are solving for?
In my two.
No, tell me the complete line. The line I used to say, I keep on saying, we have to solve for an array of input size n. That time, what is the line you are trying to solve?
Okay, I thought that divide the array into two half. One is n by 2, and check for the first to n by 2, and then n by 2 plus 2, n by 2 plus 1 to n recursively.
Okay, then try to write your equation then.
The return will be the sum, correct?
Return, yes, largest sum. Yes,
Sum.
your sum. Yes. Anything you have written? Nitesh?
Yeah,
Basically.
So, this is your recursion. Do you think this recursion will work?
बट मिडिल से ज्यादा होगा तो मुश्किल है, मतलब
What?
मिडिल चल रहा है तो नहीं होगा.
No. So you're saying I'll solve for this half, I'll solve for this half, and then just return the maximum. So you wanted your own line. This will return 4, this will return 4, and this will return 5, and you return 5. Is that a 5 is the answer?
नो अब अभी अगर एक भी केस होगा, अगर मिडिल से भी
What?
क्रॉस है तो
What?
मिडिल से भी क्रॉस हो रहा है तो अरे
I think here we can't divide into two parts. We'll have to take like one element and rest.
So, buddy, what do you think? Come again?
मैं बोल रहा हूँ कि जैसे इधर में सॉल्यूशन क्या है 4 -1 -2 1 5 करेक्ट
Mm-hmm.
तो अगर मिडिल एलिमेंट से भी क्रॉस हो रहा है तो उसके लिए
Mm-hmm.
एक कंडीशन होनी चाहिए
Okay, then how will the recursion change in that case? How will you handle that case? What will you
यहाँ
do?
कुछ यहाँ कुछ कितना है?
Asal, anything you have written? Asal?
Yeah, I'm still thinking.
Okay. Nitesh, tell me.
I think we will have to take one element and then n minus one element in recursive way.
Okay.
Not like half.
So you're saying your problem will be uh, your sub problem will be a size smaller and not just a two halves. Okay.
We can solve this in like normal way as well, no?
Like and
Like simple iteration, and
how will you do?
as we solve like manually,
What?
we'll just start a loop from first element and keep adding. And if we
Okay.
get next element bigger than our whatever addition we have, we can drop our addition and start from that point. So like if we see in our input, if we start -2 plus -3, it's -5. Then 4 comes. Then we can drop the -5. Then we can start 4. Then we'll get -1, -2. It is still it is less than 4. Then we'll get 1 and 5.
Yes.
Yeah, but recursive way, I'm not able to think.
So you will get that this can be solved in a very simpler way only, and we don't need any recursion at all.
I
Something
looks like.
we have something submitted by somebody. Okay, so array A and L and M and H. Is this what you have given, Subri?
हाँ हाँ वो नेक्स्ट नेक्स्ट उसमें हम लोग क्या करेंगे वो हमको मतलब आइटरेट करके सम कैलकुलेट करेंगे
No, see,
जिसमें
Subri, you cannot divide into sub array and then sum up because sub array and even finding the minimum maximum and then maximum of the two sub array and then returning will not work as you said कि बीच का element को कहाँ गया we didn't even consider. So you have to think about that case that will be difficult to handle. So now let's take some other approach. Which is what I'll do is I'll just iterate from beginning to end, and then I'll just keep a not keep maintain what is the largest sum till here. What is the largest sum till here? Because largest sum can end at any index. Either it can end at this only, or it can end at -3, or it can end at 4. I mean, just my point is the largest sum which we're trying to find of contiguous array that there will be an end to that contiguous array. Let's just play on that end. Let's just play on that end element. What will be the last element of that subcontiguous array? Because why that much is good enough? We don't have to talk about the first element because we know that just keep on going back until we make it 0. So it will contain all the elements before it until we add some negative to it, like until we make it 0. So if we know the maximum sum or largest sum till here, then largest sum of the full ending at this point will be sum of this and previous plus this also, depending upon if it's not decreasing the value of the maximum contiguous subarray. Okay, I'm not able to explain this properly. Let me just write something for you first, and then we'll talk. So we just have to write a loop from as Nitesh said. We don't need to do something very smart here. It's a very simple kind of question, like find the maximum value in an array. Now forget about this largest sum, contiguous, all those. This problem is something similar to find the largest element only. Just we keep on going ahead, and the comparison, the small comparison changes. Otherwise, it's just simple iteration. So I equal to 0, so I less than size, whatever size is, and then I plus plus. This is a loop. What we do is we maintain outside we have this max, current max. So something like current max we have maintained. Current max is equal to suppose 0. Okay, or 0, or let's call it integer mean value as well, because we have negative number as well. Integer dot mean value. So we start from beginning and then check what is the new maximum which is ending at that index I. What will that be? The max, current max, and then we have max at I will be equal to max which is ending at max ending at I will be max ending at one index lex plus the current value. So what is the current value? We have this A. This is A of I plus max ending at I minus 1. I'm writing this as a constant here, but we'll have to change it. So what this line makes sense. Where we have stored, we haven't talked about where we have stored this value. But if I can, for every index I can calculate the maximum ending at that index will be equal to the current value plus the maximum ending at the previous index. Okay, so what we're doing, we will maintain one more maximum ending at I. That's kind of variable. We'll maintain this equal to 0 somewhere, and we will use that. So new maximum index at that I. Okay, this is we're just incrementing, and now this value which is ending at I can be a contender for current max if this max ending at I, if this is your less than or more than your current max, then this max ending at I becomes your so current max is equal to max ending at I. So this is like finding maximum element in your array, or finding minimum. If the current value is less than minimum, then that becomes a minimum. That kind of condition it is. Otherwise, if this is not, if max ending at I is suppose negative. So if max ending at I is less than 0, this is a trickier part. If this is less than 0, then max index at I, max ending at I, or max till I will be equal to 0 now. I don't want to continue with a negative max index because that will makes no sense for me while deciding our current max. So max ending at any index I, max index ending at any index I will be equal to previous max plus AI, previous max plus current element. So current element तो होगा ही होगा, current element तो होगा ही होगा, plus the value from the previous indexes के जो भी value था. Now we have to keep on changing that. We have to keep on changing this value max index at I. If that is less than, somehow we kept on adding, and that became less. So just change it to 0. I don't want to consider any element before that. So this is the part we're doing, and yeah, this is the solution. And then what we return is we just return current max. So I'll repeat once again. We have two things. We have maintained two things. One is whatever the current max, okay, and the max which is ending that point only. So at every index I, we would have calculated that maximum ending at that index. That is max at I. That this is one thing getting calculated every time. This is changing max calculate. Let me write this below so that it makes more sense to you. Okay, I can't write it below because. So what I do is at every index I go and I just check what is the maximum of that index. So we have calculated this max at I for all the indexes. It's just that we're not storing. But we know the maximum which is being stored maximum at that I. We know the maximum at that I. So how do you know that? That will be equal to current element value plus the maximum previous maximum which is ending at I. So this is a new max at I. And now this max at I, this new max at I will be, if this is more than that becomes the current max. And after that, I just do one more check. Okay, this current max at I, which is ending here, if this is negative, I don't want that to be part of my next max at I. So just make it 0. Kuch confusion is mein? So how this is a little bit different from the DP. DP ही बोल करके हमने किया एक question. But is it DP? Can we say that this is a dynamic problem or not? This is for sure a very trivial, very brute force approach or trivial approach. The simple approach, not brute force, but a simple approach. कि क्या कर रहा है? We have to find the maximum continuous array. So what we do is we go to each element and check what is the value and what is the sum of the array which is ending here. Is it more than my till now what I have calculated? Yes, then that becomes the maximum. Otherwise, go ahead, keep on going ahead. While going ahead, just make sure you're properly calculating your max at I. In the questions like finding the maximum in an array, what you do is you just keep on going ahead, and you change your current max depending on the current value. If the current value is more than current max, then that current value becomes the maximum, and then you keep on going ahead because and the value at every index you get from there only, and value at every index you get from that index only, A of I. So you just compare A of I with the current max. In this case, the value at the value at that index which we have to compare, we have to derive first. And how can we derive that? That depends on the previous value. So we just derive the value which we want to compare. We want to compare max at I and not A of I. Okay, so we just calculate max at I by adding AI to the previous calculated max at I, and now use that to compare. Once compared, and we have set our current max, and then we just make sure that we are moving ahead. We are ignoring the max at I if all the element before, if that is the value less than 0. We don't want to add that up to our max at I further ahead because that will anyways make it negative only. So that will decrease only. So there is no use of keeping the sum after that. So yes, if you have understood this, then do you think this is DP or not? And if it is yes, how do you think it's a DP? And if not, why it's not a DP? Can you? So, but first of all, किसी को समझ नहीं आया solution ये. Athar?
Yeah, ये वाला आ गया समझ में.
आ गया. So Vadeep, do you get this solution? Okay. So do you think this is a DP now?
We can say DP because it is maintaining previous state.
Yes. So,
but it looks very simple, so I don't know if it is DP.
So not necessarily all DP has to be very tough. Okay. So this is a dynamic programming. Why? Because this every index which you're calculating depends on the value smaller than that, and either we could have done that instead of maintaining only one value, we could have maintained this an array, and then stored it there. Every time we calculated, we just stored maximum index at maximum ending at I, calculate this, and store also maximum at I, we could have stored here, maximum at I, we could have stored, and then use that for everything. But since we do not, we're not going to depend on like or more depth, we're going bottom up. It's like this is like bottom up. Okay, this is like bottom up. So in many cases, we will not be we don't need to store so many things. We can simply reuse the only few variables. So even if you take the old cases, if you're doing a bottom up, you might not need to store in complete array. But that's for sake of simplicity. What we do is we store everything. Otherwise, if you just maintain two smaller values somehow, if you maintain two previous value, then you can just use that to calculate your next value. So this will save your space. You don't have to unnecessarily. But in a top-down approach, that you'll have to maintain the array completely. This is a bottom-up approach. In bottom-up approach, you just maintain the lower value which you need to use to calculate your current value. But you have to be aware what those lower values are. So you'll have to initialize a variable called solution I minus 1j and solution I j minus 1 and solution I minus 1 j minus. These three variables you'll have to maintain, and you have to maintain and update that also every time you just change it. That's why we don't take the headache of what those three values are. It was very simple over here. How to maintain that, we just changed our max at I. Only one value was needed to be maintained while going bottom, so we just maintain that into our one variable. But in these cases, it will be difficult to consider to maintain all the I minus 1, I j minus 1, and I minus 1, j minus 1. All three sub values you'll have to update every time you go. So you have to think, okay, what will my I minus 1 be and what will my j minus 1 be? That thing, maintaining that will be a tough task, and hence we don't do all those things. We just use a space. Similarly, here we could have used a space, but we knew that maintaining is a very simple way, so we don't have to unnecessarily use an array. Okay, so this is also a DP, a little bit smarter DP, but at the end this is a very simple way of solving. So okay, smarter DP, but it's a simple question and simple solution. This you can do without even learning DP. Okay.
So
okay, everyone.
This is a DP solution.
Yes, this is a DP. Yes.
Okay.
ठीक है. Shall we move ahead? Next question.
Yes.
Athar, if you're not getting DP, then if you want to attend the last class, do you think you have missed something? You haven't missed anything. It's just we are doing lots of problems. In the previous call also we did problems. This class also we are doing problems only. Okay.
Yeah.
You haven't missed any theory, so you should be able to think yourself now. This is mostly about problem solving and thinking, and not a theory. Okay. Yes. Let's take a next question, which is coin chain problem. Heard? Okay, everyone heard about this problem? No? So this is like real life problem. We have to give some shopkeeper some 100 rupee notes. 100 rupee, we have to pay him 98 rupees, something like that. And we have to think what are the different variations we can pay him by. Like we have unlimited supply of all the 1 rupee coin, 2 rupee, 5 rupee, 10 rupee, 50 rupee, 20 rupee. We have everything. We have unlimited. So what are the number of ways we can pay him? That's it. What are the number of ways we can use those coins to make the change we want to pay him? So given a capital value n, which we want to pay to our shopkeeper, and then given a array of coins. So we have a coin of rupees 1, we have 2 rupees coin, we have 5 rupees coin, we have 10 rupees coin, we have 20, we have 50, we have something like 100. So we have all these, and we want to build this n. This is the coin change problem. Do you need anything else from me? So what you have to calculate is number of ways to add up to n using the coins. Yes, someone asking something.
Just नहीं समझ गया. Distinct coins note है basically. Infinite supply. Yeah. I think again we will do the same thing.
Okay.
Yeah, last time we did, right? So we will check अगर let's say n जो total number है which we have to add up is 10. So we don't have to care about 20, 50 and 100 here.
Yes.
And even, yeah, 10. So for 10, it will be 10. So that will be the base case here.
For
Uh,
10, why not for 10, 5 plus 5?
हाँ, so 10 के लिए 10 तो आएगा ही. That is one solution basically. One way of adding up into 10.
Yes.
Then we will backtrack, like पीछे जाएंगे फिर 10, sorry 5 आएगा. So 5 plus 5 is 10.
Yes.
That is another way. Then again we'll go back and 2, 2, 1 and 5. Again it will add up to 10.
Yes.
So we have to maintain that and we have to go back basically.
Yes. Correct. So we have to decide whether to. There are two ways, and both the ways are possible. So we have to just add both ways. There was the previous one was kind of when we choose that element, either we choose or not, and the maximum of those two. And that's slightly different.
यहाँ
Whether
पे
we
नंबर ऑफ वेज ढूंढना है तो प्लस ऐड करते जाएंगे एक एक वेव पे.
maximum करना है या plus करना है, but both the way. So
Right.
very simple problem which we have done previously. So you should be able to write like that. You should be able to write storage. You should be able to write increment also. Write the final figure. So first write the Seeger recursion. Or
I'm
first
not
write
totally sure.
the Seeger method. Fast. Everyone, just 1 minute. Write the signature of the method which you are going to
I mean,
solve.
what is n here? N equal to what?
N equal to the sum. So you want to pay 98 rupees. So that is the N equal to 98.
Okay, 90.
Huh?
What is that? What is it? N equal to 90.
98.
N is equal to 98. So N is 98. You want to pay 98 rupees to a shopkeeper, and he has unlimited supply of these points. How will you pay? That is sum you have to calculate. So N is the sum you want to find. Add it to. So will you समझ नहीं आया?
हाँ समझ में आया.
Okay. So write the signature method in the chat. Write it fast. What is the signature of the method you try to solve?
So 10 up to 9, 10 and 5 to 1.
लिखो.
हाँ. Signature.
Signature of the method people. एक लाइन का सेट कितना है बस करो.
हाँ लिख लो. काउंट होगा ना कितना टाइप से होगा करेक्ट.
Yes.
ये अगर और 8
Yes. So I have. My chart here. This you are still haven't written. This is by Subhadeep. This is by Sir Nitesh. You there?
Yes,
Okay.
yes. No.
Okay.
No.
Okay. Chat. Okay. So let's see Subhadeep now. Nitesh तुम भेज रहा है 60
Hello?
Yeah, I sending something in the signature.
No, you can start.
Okay. So this is by Subhadeep. What he will do is he will do count for array with at length and intent. Seems good to me. Subhadeep, you can go ahead and start writing the recursive call and don't worry about the edge case right now. Just write a recursive call. Similarly, your sir, you are to sum the sum of this c minus one is I think the count index and is what is this
That is coin minus one, like the number of coins we have,
and,
right?
and what is sum?
Sum is total what we are looking for.
What is n?
Oh, again, I think I have written the same thing. That should be length count.
There should be one array on which you want to work, and there should be one index
Yeah,
of the
and that
coin.
should be the last
Index,
one is the sum basically.
yeah,
N.
this is capital N or some whatever. So I wanted this. Yes. Now that you have your signature method, just try to write the sub problems and then like recursive call. What will the recursive call be?
वही तो नहीं पता कैसे लिखते हैं.
Your this problem depends on what two things or three things. This is depends on the array. This depends on the index. This depends on the n. Okay. So you have to the sub problem will also depend on these things only. What are the things you can change? What are the things you can change? So out of these three,
अरे
array
तो
तो वही
ऐसे
रहेगा,
रहेगा. Yeah.
array वही रहेगा. But I can change this index and I can change this.
minus one होगा and index
So
minus one होगा.
yeah. So this is some change index, some change the index, not necessarily minus one every time, but this question we'll talk about later. So some change index and some change n. So you think what this change index will be? What is changed value will be? This will be equal to we are saying ki let's do it minus one only. So index minus one you're saying and capital N you say what will that be? Which the change n will be. एक minus one करने का मतलब क्या है?
Sum minus one basically. N minus no.
N minus. So if you're changing
N
this,
minus yeah.
The last one, the last output.
so this will be called array of
Some change index.
index. Whatever like index minus one, not minus two. Okay. So this is the last. You ignored the last element. Hence we no, not ignored. Either you use or whatever. But this will be changed. So now we'll have to take the combination of both. Okay. So all your sub problem. I'm trying to write all the sub problem we can do. So either you have old index and change n, or it can be one sub problem can be change index but with old n, or it can be both of them can be changed, change index and change n. All three are the sub problems. Do you think all three make sense? Does this make sense? That I won't change the index. I'll include this, but still I'll change n. This is not feasible thing to say. You cannot change the index and still change the weight. What does that mean? That doesn't mean anything. Does it?
No.
No. It does. Why it does make sense. So what does
अगर index ही change नहीं हो रहा तो फिर total कैसे sum कैसे change होगा?
So what this means is we will use it, but we'll
Reuse the coin, is it?
Limiting. So either we maintain the index, we do not change the index, but we change the value. What does mean? Yes, we will reuse the coin. So yes, I'll use and still I'll try to find the solution for increased value. This is what it means, na? Nahin? So I am trying to make 98, suppose, okay, and I am right now ignore 100. Let's come to now. Either I use 50 or do not use 50. So if I use 50, then I still have the option to use 50 again. So my new sub problem will be 48. So suppose what is the index of 50? 0, 1, 2, 3, 4, 5, 6. So size is 6. So my problem was 98 and 6. So this will reduce one problem will be 48 and still I use once again. This is one sub problem. And another sub problem would be something else, but this is also one sub problem. If I solve for this, then that will help me in finding for this also. So this is also one sub problem. So this is what this means. I did not change the index, but I'll change the value. This is possible. Next time, is it possible that I change the index, but I didn't change n? What does this mean? This means I will not use it at all. That's it. This is what this means. This is also a good thing to say. And third would be that I'll change index and I'll change n, both of them. So this also makes sense, but will not write this. Why? Because this will be like this will be overlapping thing. We'll do by doing this, we will add more to our will unnecessarily add, because that this will anyway be achieved by the combination of these two. So this thing we don't have. This has a meaning, but this is not required here. If you write this, your answer will be unnecessarily increase something. So what I'm saying is this thing change n and change index, both of them will be this can be achieved from what, either this or this. So in this case we didn't change this, but we changed this, and in this case we changed this, but we didn't change this. So this thing will be the one more recursive call of this or this also. So we don't have to write this unnecessarily because this is anyway going to get captured later. So all three are sub problem, but we have to think carefully what sub problem to consider, so that we only consider all the sub problem only once. We don't end up having overlapping sums, like doing this overlapping multiple times. So yes, these are the two sub array or sub problem which we have to solve to get the value for our main thing. And any question?
Can you please repeat what is index here and what is n?
Index or length?
Let's
N?
call it length. Let's call it length for simplicity. Let's call it length.
Length of what?
Length of array which we are using to sum our n. So initially we'll start with the full length. Initially we start with 1, 2, 3, 4, 5, 6, 7. We start with 98 and 7.
Okay.
Then we find all sub problem. Do we want to include, not include everything? And that gives us three sub problem or two sub problem, whatever. And we choose which one to go ahead. So length, there's one length and there is one sum. So let's use that length now. So this new length we'll call it recursively for same length but change value, which is same length and change value. Same length and change value, which is length, smaller length, LENGT. So decrease the length by 1. Either this or decrease length minus 1, length minus 1 with the same value. So these are two possible sub problem we have to solve. I'm not writing this because this will be anyway we will reach here recursively in the later problem. So we don't have to unnecessarily include this. So these are two sub problems. Now we have to arrange this sub problem with conditions. We have written our sub recursive call. Now you have to use these recursive calls somewhere in properly. So what those conditions will be? So one condition is very simple. If your this value is big, that your array at length minus 1, if this is bigger than what you want to sum only, we will just skip this. What will that be? It will be this thing. If otherwise, we have to consider both the case. else your else you will return this plus this. Correct? Is this correct?
अभी जब ये वाला कॉल हो रहा है काउंट ऑफ ARR लेंथ एंड n माइनस ARR लेंथ माइनस 1
Yes.
तब एरे में क्या जाए एरे जा रहा है 7 जा रहा है
Yeah, this one.
हाँ हाँ
This is array, yes.
ये 7 जा रहा है लेंथ में
So we're changing these two things, length and the value. That's the only thing we consider about that. Array is just one of the parameter which is not changing at all. So we are changing in this case. We will use we can use, hence we'll use, but and this is what I mean by use. But I don't want to remove this value because I want to reuse it. So I can reuse. This is what I mean reuse. In this case, okay, I don't want to reuse anymore. Just go ahead and for the next part. This is two solutions: reuse and not reuse. If we can, first of all, if can we use or not? If we cannot use, then for sure we'll have to just skip it. If we can use, so there are two ways: either we use or we do not use. If we use, then this is a recursive call. If we do not use, then this is a recursive call. Okay, so the third part which is recursive call which we haven't released, I use also and just I go ahead. That part we don't need to it because that is covered anyway. We'll cover it with this only. That I use it, but I want to reuse. So this will call that recursively, and these two will sum up to the final solution. Is this recursion clear or still some issue?
Can we dry run at least a little bit?
Yes. So 98. We started with 98.7 or let's not 98.7, which means I'm talking about right now this 100. Do we consider this 100 or not? So it will say no, 100 is more than. So this is array.
798. Okay.
Then we have capital N equal to 98, and then we have our length equal to 7. At this point, what we'll do, we'll check. So array of 6 is equal to 100. This condition will check. Array of 6 equal to 100. Hence, we'll just call recursively for one more n equal to 98 only, but with length decrease. Length and GTH equal to 6. Now this will call recursively again. Just go again, and this will check if this condition won't be satisfied. Hence, we'll go to else part because our array of 5 is equal to 50, and it's not more than 98. Hence, we should be able to consider both. So, what those two recursive call will be? One will be for n equal to 48 and length equal to what is the length? No, let's do the yes, n equal to 98 and
that will be 5.
length equal to 5, and then one more will be n equal to 48 and length is equal to still 6.
48.
So this will call recursively more.
Right.
So this will call for two. This will also make 2 calls. One will be n equal to still the same 98.
Length will be 4.
And this will at 5 length we'll have to 78. It will call for 78 comma 5, and this will call 48 minus
48 5.
48, and we have to change the length 5, and this will be 48 minus
28 6.
No, wait just a second. So we have 48. 48 will be no. This has six index. Six index will simply call it 48. Nothing else. You simply call 48. Nothing else. Confusing. This will make only one column. This condition will come up. That your value at 5 is 0, 1, 2, 3, 4, 5. Your array of
हम
array of
लेंथ ले रहे हैं ना, तो लेंथ 0 से नहीं ले रहे हैं हम लोग, हम काउंट लिए टोटल.
this condition array of length minus 1. So array of 5. What will that be?
Array of
at length equal to 6. At length equal to 6, we have array of 5 is equal to more than 48. So we'll simply just decrease the length and we'll still keep same value. Only one recursive call here. नहीं?
Yeah.
This is what we did here. यहाँ पे किया हमने same thing करना. So yes, you'll keep on doing. Now we have to add our base condition, which we haven't written any base condition yet. So let me write the base condition. So ये समझ में आ रहा क्या?
Yeah, समझ गया अभी. Yeah.
Now let's write the base condition. So if your this whatever you want to calculate, that capital N, if you capital N is equal to you don't have then in this case you have no only one way to do this. Return 1. That you what is the only one way? Don't give any. Don't give any.
Yes.
N equal to. So this is one way that how to make sum for 0, which is like don't give any coin. This is also one way, no coin given. So what is the number of ways we calculating is, and then what we want to calculate is the, coin one is given how many coins are part of it? N1. Sorry. Coin 1 is used N1 times. Coin 2 is used N2 times. So this is the number of ways. So I want to add in all the coins. Like coin N, coin 100 is used some nk times. So this is what we have to calculate. How many each coin will be used? All these are ways. So this is your 0 time. This is your 0 time. This is your 0 time. All of them are used 0 time is also one way. This is what return 1 means. We will not use any coin and we'll just make it this is equal to return 1. And then while doing this, while decreasing length, if n is less than 0, or sorry, if length len gth is less than 0, which means length equal to 0 means length equal to 0, length less than 0.
Return 0. If length ही नहीं है तो कोई coins ही नहीं है तो return 0 हो जाएगा, कोई chance ही नहीं count का.
If there is no coin only used, then what will the answer be?
Return 0.
Return 0. If we cannot use any coin, then there is no way to build this. Okay. Base condition. Any other base condition?
Less than 0, n less than 0, less than equal to 0. वही first condition.
And equal to 0 you want?
Condition अलग हो जाएगी, less than 0 हो जाएगा तो.
And less than 0, I do think we'll ever be able to go to the capital N less than 0. We can decreasing only when we can decrease. Other decrease नहीं हो रहा तो we don't even decrease. Okay. So N less than 0 won't even reach. Okay. Capital N less than 0 कभी जाएगा ही नहीं. We'll always start with. I mean ठीक है ये कर. That is a very. This will be ever reach. We will not even reach it. But let's get ठीक है. So with this base condition, with this terminating condition, our recursion will stop. We have a stop. We have a condition on n. We have a condition on length, both of them. So ये जो recursive call है जहाँ पे n और length change हो रहा है, ये जो recursive call है n और length change हो रहा है, all these will stop somewhere and then return and then we'll use the recursion. ठीक है?
Yes.
Now with this recursive, how much time do you need to write the DP with this recursion?
Oh, आंसर नहीं आया क्या अभी?
I'm asking time, not an answer only.
Okay.
Not even time complexity. I'm just asking. Tell me the time. So what is time complexity of this recursion, by the way?
Exponential
2 to the power n.
n.
I mean, not just n, but 2 to the power this either whichever is bigger. If n is bigger, 2 to the power capital N, or if length is bigger, 2 to the power length, but 2 to the power something, which is exponential. Okay? Whichever is bigger, 2 to the power whichever is bigger. Okay?
Praveen, one question.
2 to the power, just again, 2 to the power n, where n is max of both the inputs, which is one input is length. Obviously, most of the need to be this only bigger, but yes, tell me.
So we are calling this the same method twice.
We are calling the same method twice. Which where?
The last line, right? Return
Yes.
count plus.
Yes.
That's why it is 2 to the power n, right?
Yes.
If we were calling it 3 times,
It will be 3 to the power n.
okay.
First.
Okay. Cool.
So e to the power n is the exponential. E to the power n, 1 to the power n, or will be exponential. Okay, you start. I have a call to take. Okay. Start up thinking about the DP solution, or first of all storage.
Can you scroll up a little bit, please? Thank you. Praveen?
Anyone asking?
Praveen, can we store like storage as a double dimensional array where it could be length, comma, and size?
So you want to store the value somewhere. So let's call it output this time, which is an array.
Yeah, so first will be length,
length, length,
and second will be n, capital N.
capital N. Okay.
This could be our storage, right?
So and what do you want to calculate in after storing everything? What do you want to calculate return? Yeah, size is length plus 1, and this is what to store return. Correct? This is correct.
Yeah.
Okay. Yes. We'll initialize the array of size length plus 1 and n plus 1, and we'll keep from 0 to n. We'll calculate and return this length and n. This is I think this is okay. Others. Atharva, Subodhi, do you get this storage first? Once you have the recursion, you have the storage. Now you have to implement using this storage and using this recursion. You have to implement your complete DP. Subodhi, समझ रहा है?
Yeah. Thank you.
Yeah, go ahead and try to write the recursive part. Don't worry about the edge case. Just write the main part, which is this part.
Praveen, this storage is clear, but you said the second line that will return this, that I did not understand. Output length.
So at that what you want, you store so many things and you calculate so many things. So what is the actual answer? What is the actual answer? You will calculate your output of I, J, and I plus. So at the end we want to calculate N and 78. Okay, 7 and 78. But you'll calculate your 3 and 50 and 4 and 28, something like that. You keep calculating. But the answer is what we want is only for N and 78. So while calculating this output and storing everywhere, and then once we have calculated everything, we just return this part. And what this part means is, we have to initialize an array of size 7. Length is 7. Okay, yeah, this is length plus 1. So length is, what is the length of this array? This is 1, 2, 3, 4, 5, 6, 7. So this will be of size 8. No, length is 7. Length is 7. So this will be of, we want to calculate for, we want to return output of 7 and output of, yes, output of length is 8. 9 is 9. So what okay, this is the array we want to initialize, and then what, this is size. Okay, we have initialized an array and we have to return. Some mistake I'm doing, we have to return for length is, yeah.
$98.
Yeah. ठीक है?
Okay, ठीक है.
नहीं समझा.
नहीं समझा?
नहीं, स्टोरेज एक बार फिर से बता दो, ये टोटल ये 3 लाइन बस.
Yes. So we want to calculate your array. So we want to calculate the number of ways to add up to n using the coins from the array, this array. And what is the size of this array? The size of this array,
7.
length, length is equal to array dot size. So this is the length of the array, and capital is still capital into 98 here. And this is equal to 7. So we want to store all the values in our output array. This is the output array we want to store, and thus I'm trying what is the size of this array will be. तो वो सोचना है हमें. Okay.
एक्स्ट्रा क्यों ले रहे हैं दोनों इसमें?
What?
एक्स्ट्रा +1 क्यों कर रहे हैं दोनों?
हाँ, तो because we want to at every index I comma j, at every index I comma j is equal to value, whatever value we get, value at I comma j. What is the meaning of that thing? If that is clear, then you'll know why you are using that. It's equal to ways to form or ways to form j using array of size I. तो ये हर सेल में ये स्टोर होगा, हर से all the cell of output, not output के output लिखना होता है. What each cell will contain, the ways, number of ways to form j using the array of size I. This is what it means. At the end, what we want to calculate is, what do you want to calculate? We want to calculate output of not calculate, but what to return is output of this.
That is number of
Outputs.
ways, right?
Yeah, number of ways total. तो ये हर सेल में है, तो हमें ये वाला सेल का वैल्यू चाहिए, है ना?
Right,
अगर हर
right.
सेल ये है, तो हमें ये वाला सेल का वैल्यू चाहिए. For us to have this cell value, the what is the array you will initialize? So size has to be 8 ना. अगर size 7 रहेगा तो फिर output 6 last में 6 होगा ना. तो this is the you have to initialize anything bigger than that, not तो अगर size 8 है तो ही तो output of 7 मिलेगा. 0 वाला प्रॉब्लम जो है. Similarly size अगर 99 है तो ही तो 98 वाला index मिलेगा. What will the in this, let me draw for you now. Why this is confusing? Color बहुत खराब है. So this is size. What is size? 1, 2, 3, 4, 5. This is size 4. 1, 2, 3, 4, 5. This is also 1, 2, 3, 4, 5. This is also 5 only. Okay. So what is the index of this? This is 4, 4. है ना? तो वही जो है size लिया है. We have initialized with 8 and 99, so that I can get 7 and 98. ठीक है?
Right.
Yes, write the recursion fast. No, sorry, the DP fast. We have the recursion, we have the storage. You write the DP. कुछ भी अभी भी confusion बता. I won't agree to the fact you're not able to do it anymore. अब तो सब कुछ हो गया है. बस repeat करना सब कुछ.
कर रहा हूँ कर.
You will only do it. I know you can do it.
Praveen,
Yes.
chat.
Sorry. Yeah. Okay. So for I less than I0 to less than length, for j 0 to less than n, just calculate your output of I is equal to output of I minus 1 j and j of a minus I. You use simple recursion we have replaced. Above also the same thing. Anything else? Now, so believe that this looks good. So
Yeah, 5 minus 1, last one.
what?
आउटपुट लास्ट वाला आउटपुट ऑफ I j minus a of I minus 1.
Okay. So let me see. Let me have a look first. Just a minute. You can try to write your base cases on initializing thing also. Meanwhile, okay. Somebody.
Okay. Yes.
Anyone else? Yes, there is some chat. Sorry. Nitesh, Subhadeep कुछ भी है या फिर shall I move ahead with the solution?
सेकेंड लाइन नहीं हो
क्या सेकंड लाइन नहीं होगा?
ओ सेकेंड और थर्ड
Okay, we'll see. Nitesh,
Yeah.
everything, anything? Subhadeep, you? Sorry, Atharv, you? Subhadeep तो लिखा ही है.
No. Not yet. Still.
क्या दिक्कत क्या हो रही है? What is the problem? क्या नींद आ रही है क्या?
नहीं
फिर तो बहुत सिंपल सा लाइन लिखना है. मतलब once we have a recursion, using this recursion and you have your storage thing also done, you are simply doing now things are clear. You have to do a bottom up kind of model. तो भी तो हो जाना चाहिए.
we have to repeat the same thing which we have written, right? We have to
Yeah.
just store that count basically.
Yes.
Mm. Yeah, that I understood. That is what even Subhadeep sent for output IJ. That
Yes.
that thing. Mm.
Yes. This only you have to write.
हाँ खाली कॉपी किया वो देख देख के
Yes.
लूप लगा के
Right,
Yes.
right.
This is a bottom up approach. You start from 0, 0. You calculate for each all the smaller values, and then try to reach your final answer. This is correct.
इसमें आई और जे पहले जीरो डाल दिया इसलिए वन से चलेगा मतलब जे इक्वल टू वन से चलेगा लूप जे इक्वल टू
Yeah. ठीक है. I mean, this pseudocode is fine. Then we can write implement completely. It is you go to यही करना है हमेशा. We just go to each index and we try to calculate the value of that index using the old value. So this old value this also must have been calculated because those both indexes are less than your ij. So this would have been calculated previously. This would have been calculated previously. Just use those two to find the sum here, to find the final output. यही तो है. हर बार यही कर रहे हैं. हर क्वेश्चन में यही कर रहे हैं. ठीक है.
Yeah, but हर बार बॉटम अप अप्रोच ही यूज करेंगे ऐसा. अगर रिकर्शन पता है तो फिर ये तो आसान हो गया. यानी वही सॉल्यूशन लिखने हैं, राइट? सेम. It's similar to recursion only then.
Yeah, so this is bottom up, and which is easy to write. You can try a top. Let's try a top down for this. Okay, let's try a drop down for this. So we have our same thing. Where is that? This thing initialized. Okay, using this array initialized. What we'll do is we will first in our output. So I always suggest you go for top down, bottom up first. If you're only not able to only think about the top down. So this is, let's try to write top down. Output of what? Whatever length len gth, n will be equal to this, and return this. Similarly, here also the same thing will happen. Equal to this, and then just return them. So that next time when you come inside, if this is already calculated, if this
Equals to nil.
is equal to minus or something,
-1. Yeah.
whatever, just return. Don't go deeper. Return this. ये भी top down approach है, but bottom up is a little simpler, so we don't have to do that. Do the same thing. Okay, this looks more clean, by the way. This is more easy to understand, but both are okay. Both you can do.
Can we solve all the problems using bottom up then?
I didn't say that, and I can't guarantee that.
Okay.
बहुत अच्छा होगा
So this question was related to sum of count, or like we are checking number of ways, right? So
Yeah,
that was the reason we added these two outputs.
Yes.
Otherwise, if there is largest element we have to find, or something largest subarray or something, then we will just use maximum of these two outputs.
Yes.
Okay.
Correct. तो सब प्रॉब्लम को यूज करके कुछ निकालना है. वो मैक्सिमम निकालो, मिन निकालो, सम निकालो, डिवाइड कुछ भी निकालो, या कुछ और ही लॉजिक बूलियन निकाल लो, कुछ भी कर लो, बट सब प्रॉब्लम को यूज करना है.
So एक क्वेश्चन है इसमें. ऑलमोस्ट सभी आंसर्स सिमिलर टाइप ही लग रहे हैं. Like we are either reducing it, like एक अगर अरे है तो हम पीछे से आ रहे हैं एक माइनस करते basically most of the questions में.
Yes.
So mostly ऐसे ही similar questions रहते हैं. Let's say हमने एक largest सब अरे वाला एक प्रॉब्लम कर दिया. So does that mean कि largest अगर word भी दिख रहा है तो we can try for that thing? नहीं, right?
I'll give you a question जिसमें ऐसा नहीं हो रहा है, कुछ और हो रहा है. ठीक है.
Okay.
The question is, given a 2D matrix, you have to find the shortest path from 0 to nn, from 0 to nn. So the arrays of size suppose n by m. So from 0 to mn, you have to reach from 0 to mn, and you have to find the shortest path. And each cell contains the value of that path. Each cell contains the value of that path. Yes, try to do this. I'll try to write this question. First, I'll draw something, and then I'll give you the. So, given a 2D matrix. Given a 2D matrix, you have to reach from this index to this index, and each cell contains some value. Okay, I'm not writing anything there. So you have to find the shortest, not shortest, but shortest, cheapest path. Okay, you know, cheapest path to reach from here to here, the minimum cost path from here to here, and the constraint are you can only move right. I mean, this is on this direction horizontally on this side, or you can move down, or you can move diagonally. These three paths only you cannot go back. You cannot go up or left. You can only go increment your I, or you can increment your j, or you can increment both, but you cannot decrement any index. So what is the shortest or the minimum cost path from 0 to nm? Try to solve this.
ये टॉप डाउन होगा क्या, पीछे से ही चालू करेंगे?
वो मुझे नहीं पता, तुम सोचो.
एक्चुअली ये प्रॉब्लम में टॉप डाउन या बॉटम अप आई थिंक डजंट मैटर, क्योंकि अगर ऊपर से जा रहे हैं तो भी नंबर कुछ भी रह सकता है नीचे से जा रहे तो भी कुछ भी नंबर रह सकता है.
बेटर इसको सर्कुलर कर दे, 0 to nm at point.
So actually, Athar, even this problem, if I think, मुझे याद नहीं solution याद नहीं था, but even this problem is on a similar lines only. Whatever we have done till now, let me think of some other problem. Meanwhile, you do this. So this is also a similar kind of, but not the different. I want to give a different problem, but ये करो at least. ये तो similar तो खाना हुआ करने के लिए. जल्दी से कर दो इसको.
प्रवीण, एक बार क्वेश्चन रिपीट करना.
अच्छा, repeat the question.
So ये मैट्रिक्स दिया हुआ है, एक कोई भी एक ब्लॉक से कोई भी दूसरे ब्लॉक पे जाना है, और हर ब्लॉक में कोई मिनिमम कोई भी वैल्यू दी हुई होगी, 0 1 2 n 100 कुछ भी, और ऐसा एक पाथ निकालना है वो ए से बी तक जाने के लिए, जिसका मिनिमम वैल्यू रहेगा, मिनिमम कॉस्ट निकलेगा. कॉस्ट है ना, यही नंबर कैलकुलेट, टोटल सम निकालना है बेसिकली.
Okay.
Minimum sum basically.
It's a sample.
और एक है कि हाँ.
Suppose this is sample path.
हाँ.
Sum of all the value in this. Sum of this plus this plus this plus this plus this plus this plus this. Okay, so sum of this, and this we want to find which path. There's one path like this. There's one path like this. There's one path like this. There's so many paths possible. I want to find the cost of the minimum cost path. Which path has a minimum cost? Okay. There's so many paths, but there is one path which is a minimum cost. That, and what is the cost of that path? I don't care about the path. Yeah, just return the cost. That's it. Minimum.
इसमें इनपुट आउटपुट क्या है?
Input. You tell me the sign of the method, signature of the method. बहुत क्वेश्चन पूछ रहा हूँ मैं.
अरे तो रहेगा ही, आउटपुट रहेगा इंटीजर. हाँ, इंटीजर अरे.
This is the input on which we want to work. Okay. And give the minimum first part on this integer array, capital A. Yes. What else?
और टोटल सम रहेगा, लाइक कॉस्ट बेसिकली.
कॉस्ट तो फाइंड करना है ना.
हाँ, पर एक सम रहेंगे ना जिसमें हम कैलकुलेट करते रहेंगे ये सब कुछ.
That's up to you. You want to maintain that into argument only, sum into calculating, or do you want to
Okay,
just?
we can use it. Okay.
But अभी तो जितना solution किया, did we do that? So let's take this. Did we do anything in this? हमने कुछ maintain तो नहीं किया था sum. We just
Right,
done
right.
नहीं है. That is a special kind of regression where we pass the जो calculate करना वही pass कर दिया, उसी को change कर दिया. That is also one kind of regression, but not necessarily we'll do everywhere. So let's suppose this is there, and we have the return. What we are returning is the cost. So int. With this, try to implement. And let me think about one more question, which is not similar. I'll go back.
वही सॉल्यूशन होगा कुछ विदाउट टेकिंग लास्ट.
लास्ट वाला पूरा एग्जैक्ट रेप्लिका रहेगा. इसमें आई थिंक और एक केस ऐड हो जाना चाहिए. हम लोग जो अगर छोड़ रहे थे शायद.
हाँ, लग रहा है अभी एक प्रॉब्लम तो सभी सॉल्व हो जाएगा.
बहुत टाइम ले रहे हो.
अच्छा, वही सर. I-1 N-1 M-N-1 और उसका मिनिमम.
Yes, just write the line fast.
अच्छा हाँ, ठीक.
Nothing or something आ गया. Riju is on fire today.
मान ही नहीं रहा लड़का.
नहीं कुछ उल्टा सीधा ही मैं डाला हूँ लग रहा है.
मेरा सॉल्यूशन लिख दो.
नहीं और एक क्या कर दिया.
Okay. Nitish,
Mine is same as Athar.
कल रात को पार्टी वार्टी किया क्या तुम?
हाँ.
कुछ तो लिखो चैट में.
WhatsApp
अच्छा फोन पे कर रहा है क्या तुम कोड?
हाँ WhatsApp पे.
वो किताब पे कर रहा है, किताब में.
ठीक है तुम रहने दो फिर. तो this is the
WhatsApp में
recursion.
गया मेरा.
This is the recursion, which is again the first part. So to calculate from 0 to nm, we need, so there are, how come we are writing 3 subproblems this time? How will you identify this? So this
Diagonal also.
this is the part we have to identify. The subproblems जो होंगे वो कितने subproblem को use करेंगे हम लोग? Sometimes most of the time
3 blocks were nearby.
What?
We had to choose between like 3 paths.
Yes. So that's also one part of the recursion. You always have to think ki, what are the subproblems we need to know the value of subproblems to get the value of the main problem. What are those subproblems? So most of the time we have only found 2 subproblems, and hence using those 2 it was okay. This is 3 subproblems, and hence the complexity of recursive call would be
3n, 3 to the power n.
Yes. So to reach here, there are only 3 ways to reach, either from here to here, here to here, or here to here. These are only 3 possible ways. And we know कि if you find the solution from here to here somehow, and from here to here somehow, and the third way is from here. If we can find the value of these 3 subproblems, then we can just check which one is better by comparing whichever is better is the minimum cost, and the final cost will be sum of these 3. Of course, this minimum plus what? Plus some cost, plus the cost of a of n whatever.
0 0 or what?
This minimum plus a of nm whatever. Minimum of all 3 plus this. This is the total minimum. ठीक है? सबको ये पार्ट सबको समझ में आ गया इजीली?
Yes.
Yes.
ये plus a and m क्यों लगे थे?
अरे. So what way is your solution? Is this your solution, Subhadeep?
और एक ऐड करना पड़ेगा in my I minus 1 to minus 1.
ठीक है, we'll see that. So who asked this part कि plus क्यों लिखे थे?
No, that's the Athar solution, right? You added plus a of nm.
Yes. So यहाँ से इसके बाद plus करना पड़ेगा ना. This is the minimum value of to reach one step.
Okay.
This is the minimum to reach one step. So plus the that part.
Got it.
Yes. So similarly,
half the cost, correct?
Yes. So similarly, also, Subhadeep, you have also done minimum, but you haven't added the last part. We are calculating we're trying to calculate the path to reach nm. So before that, जो time लगेगा, cost लगेगा, plus this cost is a little bit missing here, but whatever, we'll check that. Plus a of I j plus these 3. इन तीनों में से कहीं एक पहुंचना पड़ेगा. So whatever Athar gave was the recursive solution, and this is the DP part of it. So the DP solution for same. So minimum cost, we are going from bottom to up. Okay, bottom up approach, top to bottom approach, where we are calculating for to reach everywhere next 0 से 0 1 पहुंचने में 1 1 पहुंचने में और 1 0 पहुंचने में वो तीनों कैलकुलेट हो गया. And using those three values, we'll go step one step further. And it's like we are covering everything, and at the end we are reaching our NM. So this is a bottom up approach. Very simplest way to code. You can try to write your top down also, but that won't be a much of help. So this 3 to power n has been reduced to how much? What is the time complexity of this solution?
NM.
NM. ठीक है?
Same.
टॉप डाउन का भी सेम कॉम्प्लेक्सिटी रहेगा?
हाँ, टॉप डाउन का करो या बॉटम सेम ही रहेगा.
Okay.
Yes. So what will the like base cases and all those cases? वो क्या रहेगा?
अगर 0 0 पे ही है तो उसका सिर्फ डायरेक्ट कॉस्ट ले लेंगे.
Yeah. So one of the base
value of A.
अगर स्टार्ट पॉइंट और एंड पॉइंट एक ही है, वहाँ फर्स्ट ही है या कहीं से भी, तो वो पर्टिकुलर वैल्यू लेंगे.
Yes, that will be good enough, but will that be good enough? So suppose I reach 0,2. So 0,2 क्या करेगा? अपने left देखेगा अपने. So apart from that base case, you also have to handle the edge case. Base case is to terminate your like recursion, which and similar to that we have in our base values. But there's no edge case also. Edge case भी सुनना पड़ेगा. So somewhere edge case and base case different. Base case is like okay, so that we don't go deeper. But edge case क्या होगा? If we are doing for 0,3, don't check -1,3. If you are at the index 3,0, don't go for 3,-1. वो सब handle कर लेना है. What will that be? Okay, so I'm handling those edge cases as well as base. So first, let's before we start also just write the what is the output of 0 and 0 is equal to how much? Is equal to A of 0 0.
A of 0.
This is the base case or the base value. Okay, अगर ये क्या नहीं सेव करेंगे तो यूज क्या करेंगे आगे, बट ठीक है. So I'm just trying to tell you the difference between base case and the edge cases, and now we're writing here the edge cases. If I equal to 0 and j equal to 0, what will do in this case? You will have to you cannot do simply -1, but that will go index out of bound. So उसमें केस में क्या करना होगा वो बताओ. That will be only output of ij will be equal to what? Tell me क्या होगा?
A of ij.
A of 0 0.
Let us separate this for you. A of ij क्यों होगा?
0.
j equal to 0 क्या करने हैं? हाँ, so this is for I equal to 0. We're not changing the row. We just changing the column. सिर्फ j change हो रहा है. तो आगे बढ़ रहे. तो what will the value for A of 0,3? क्या होगा? A of 0,3 पहुंचने में क्या लगेगा? So
J.
नहीं.
J और I.
So this is your
A of 0,3.
0j. 0j. What will that? So this is A of 0j. Suppose this is इसका वैल्यू किस पे डिपेंड करेगा? The only way to reach here is this. We cannot reach at it from anywhere else. I cannot write this.
J minus 1.
Oh.
Whatever. Yeah. This will depend only on this. So it will be equal to
A
this
of
value.
I j minus 1.
Value of this plus this. ठीक है? Similarly,
Yeah.
similarly this one also we can reach only from here. So value of this value will depend on the previous value here plus this condition. That's what I've done. For I equal to 0 and j equal to 0, both the cases. For I equal to 0 and j equal to 0, we have to write it separately. Otherwise, we'll face the problem of index out of bound exception, whatever. So I equal to 0 है तो I equal to 0 है अगर, and that will depend on I same I but -1
J minus 1.
plus A of ij.
Yeah.
And the same part of the whole यहाँ भी रहेगा.
क्या होगा? I minus 1j.
हाँ ठीक है, अब तो कोई बता देगा. ठीक है, next. So we have done our similar kind of DP. Just decrease the just go bottom up, keep on calculating one by one, and then the sub problem is just one smaller sub problem, one value smaller. And in this case there are 3 sub problems, not slightly different from previous where there were only 2 sub problems. In this case we have 3 sub problems. But one thing is still common is 2D DP. Okay, 2D DP. Most of the DP we are doing is 2D DP. 1 DP we did was 1D, which was some sort of Fibonacci, only 1D DP, but these are 2D DP. Okay. Now, and the complexity of this is 3 to power n. So now I'll tell you, I'll give you a question which is NDDP, NDDP,
मतलब
NDDP, ND, 1D, 2D, 3D, 4D, ND, NDDP, n-dimensional DP. So don't get scared. It's not something very big thing. The thing is your sub problems. You cannot tell whether how many sub problems we will be using. But we'll have to think how many. Sorry, not NDDP. It's not NDDP. But wrong word. Not NDDP. What we'll do is we don't know how many sub problems we'll use. That's my point. That's not NDDP. So right now there are 3 sub problems. Previously there were 2 sub problems, but now this is the question I'm going to ask. We will have variable number of sub problems to calculate the value for this current problem. This current problem, big problem, will need the solution of multiple sub problems, not just 2 or 3, but multiple of them. How many, that varies. But my point is the solution of the main problem depends on multiple sub problems, not just 2 or not just 3 or not just 1. Multiple sub problems. That is not an NDDP. NDDP is something else. So again, this NDDP is defined by me, so I can change it. This is not NDDP. So let me ask the question now. So question is given they've given this is again minimum number of jumps. So given an array which has values 1, 3, 5, something like that. So we have to find a minimum number of jumps to reach the end of the array. So you start from the beginning and you have to reach the end of the array. Sorry, what happened? So question is minimum number of jumps to reach the end of the array. Minimum number of jumps to reach the end of the array. What is the array? Yeah.
Frog
array.
वाला problem.
What?
Frog.
Frog.
Frog minimum jump.
I don't remember the frog problem, but I can make it a frog problem. So there's a frog starting from the there's a frog starting from the first index, and he can only jump. So whatever. So at every step he has some energy. Okay, some energy at that step. Energy 1, energy 3, and he can jump only that many number of steps. He can jump only that number of steps. So from this index, he can only jump 3 ahead. Okay, from this step, he can only jump 5 steps. So what we are finding minimum number of jumps so that he reaches the end of this river or lake or whatever frog problem. So I'm not talking about frog problem anymore. So my point is, you start from 0th index, you have to reach the last index, and you can jump whatever the value. The maximum jump you can make is whatever the value is at that index. That is maximum. You can obviously go jump less. So from here, from this index, you can either go to 0th this 2th index, 3rd index. I mean, you can jump 3. You can jump 1 step. You can jump 2 steps. You can jump 3 steps. And you can choose any. Either you jump to this place only, or you jump to this place only, or you jump to this place only. So you can jump to any number of any place, not just the maximum, but anything less than maximum. Okay? कहीं भी jump कर सकते हैं. So which
restriction क्या है यहाँ पे?
From at any index I, you can only jump a of I ahead. You can jump maximum a of I. You can jump less than that, but you cannot jump. You cannot go from 2 to this. You cannot jump from this 3 to this 2. You cannot come from.
Because that's 3.
यहाँ से यहाँ जा सकते हैं, यहाँ से यहाँ जा सकते हैं, and यहाँ से यहाँ जा सकती है. 3 possible option है हमारे पास.
Right.
Which one you will choose so that you reach 9 faster? हो सकता है कि you in the greedy approach you try to jump as far as possible, but वहाँ पे कट जाएगा, वहाँ पे जाके पता चला कि यहाँ पे 2 ही है और यहाँ पे थोड़ा शॉर्ट स्टेप लिया होता तो शायद फायदा होता है, यहाँ पे एक स्टेप शॉर्ट लेने के बाद लंबा स्टेप मिल जाता है मुझे. तो yeah, that's what the question is. So given an array, you have to find the minimum number of jumps to reach the end of the array from the start. So may I have a question?
Yes.
In this case, what will the number? What do you think the answer be? Like, what is the number of jumps? So, what if I jump from 1 to 3, and then 3 to 8, and then 8 to 9 directly? Or we can jump from 1 to 3, and 3 to 9, and 9 to at the end anywhere. So, both of them are the minimum number of jumps. This is also 3 jumps: 1 to 3, 3 to 8, 8 to 9. Or the other one was 1 to 3, 3 to 9, and 9 to 9. Both of them are the same number of steps. So the minimum number of jumps required to reach from start to end will be 3 jumps. ठीक है?
एक बार कांस्टेंट समझ में नहीं आया.
क्या समझ नहीं आया?
वो कांस्टेंट क्या है, मतलब रेस्ट्रिक्शन.
Constraint क्या है?
It does not have to reach the end of the index. Sorry, it does not have to reach the end of the array, right?
We have to reach the end of the array. What's the problem? We have to reach the end of the array. What do you think? So, what constraint समझ नहीं आया. Constraint, you are traversing in this array from beginning to end. You have to go from you index, like first index, third, second, first index, second index, third index, fourth index. You have to go from start, and you have to reach your last index. Now, while doing that, you can jump. You can just go from 0 to this position, but that jumping has a constraint that you cannot jump more than whatever is the value at this index. Let me again rephrase.
Okay, समझ गया.
You can jump less than that number, but you cannot jump more than that number.
Okay, fine.
Okay.
Yes.
1 to 3, 3 to 8, and 8 to 9.
From 3 he can go either to 5 or to 8 or to 9. So, but he chooses to go to 8 and 9 and not 5.
बस नहीं, अगर 9 होता तो डायरेक्ट जंप कर देते थे.
हाँ, तो तभी तो मैं कह दोनों सॉल्यूशन ये है, because either you jump to 8 or you jump to 9. In both the cases, you will reach your end in one step. So that's why total is 3 only. So दोनों आंसर करेक्ट है. But what I want is number of jumps and not about the path. I don't care about the path, just give me the number of jumps. अगर पाथ करें होता तो फिर एक बार डन करते हैं लोग.
ये भी काउंट जैसी हो गया.
हाँ, इसमें प्लस होता है.
हाँ, एक्चुअली नंबर ऑफ वेज नहीं करना है, मिनिमम नंबर करना है.
Praveen?
Yes.
I have an approach. I don't know if it is DP. So we'll start from end of the array.
Okay.
So from end of the array, we'll see if we'll go till 8.
Yes.
The second 8, because the length is less than 8. And then we'll mark that as a one jumping point. Then from 8 we'll go till 3, because from 3 we can reach 8, but from 1 we cannot reach 8. So 3 will be another jumping point, and the 1 will be the first jumping point.
Nice one, Maya. Can you repeat everything like you're coming from back?
From back.
Okay.
So we'll find an element from where we can reach the end.
From where you can reach 9.
How
will you find that?
So when we'll traverse from 9, right, we'll go to 8. So yes, from 8 we can reach 9. We'll look for another number. Then 7 also, yes, we can reach. From 6 also we can reach, but from 2 we cannot reach. So we can like
you'll find all the places from where you can reach 9. Okay, but after that,
After like so, 8 is the last point from where we can reach.
okay, the last point where you can reach is 8. Okay,
8. So we can put a marking point there. Like let's say this is like one jumping point,
why
and
do
then
you think?
we'll
Why do you think? Why do you think the last point will be so among
8.
all those options? Among all those options you had,
Yeah, yeah.
wait, just wait a second. So among all the options you had 8 and these, why do you think you will choose this 8 only and not these? Why do you think that?
Why?
Can you
Because
explain me? Yes.
we are covering a large number of distance, right?
हाँ that but that seems to be greedy approach, little bit greedy कि जहाँ से सबसे ज़्यादा फायदा हो वहाँ चलो. But don't you think कि यहाँ पहुँचना would be suppose now the problem is just यहाँ पहुँचना. Okay, from start हो सकता है ऐसा हो कि यहाँ पहुँचने में बहुत टाइम लग जाए rather
हाँ,
than
ठीक है, समझ में आ गया ग्रीडी अप्रोच है.
हो सकता है कि यहीं पहले ही पहुँच के मैं यहाँ जंप करके एक स्टेप निकल जाऊँ कंपेयर टू एक पहुँचने में ज़्यादा.
हाँ हाँ, ये ग्रीडी अप्रोच हो गया.
And actually it's not just a greedy approach problem कि greedy कर रहा था इसलिए problem था. The problem was we're not even sure कि 8 तक पहुंच ही पाएंगे नहीं पहुंच पाएंगे. That was the main problem. The greedy approach would have worked if you can guarantee 8 पहुंच पाएंगे नहीं पहुंच पाएंगे. So you'll have to do a backtracking. Okay, 8 पे निकालते हैं 8 पे पहुंच गए अच्छी बात है वरना फिर let's try for something else. That backtracking all will come into picture. So we don't want to do that.
Yes.
What we can know at from beginning that what are the next places I can reach, that I can know, but
Yeah.
start from that side and think. Not a single solution yet. है क्या कुछ? You only tell me when you give up. I won't be asking now. नहीं होगा मुझसे बोल दो.
थोड़ा हिंट.
Just think about pseudocode first. For code, just pseudocode क्या लिखोगे? And do we have a signature of the method yet?
सिग्नेचर को लिख सकते हैं. सिग्नेचर ऑफ द मेथड डिफेंस कैसे करेंगे? एक ये भी ले सकते हैं.
array और index.
एरे और लेंथ ले सकते हैं. और एक स्टार्ट एंड भी ले सकते हैं. ये भी कर सकते हैं. बट अभी स्टार्ट एंड लेने से भी कोई फायदा नहीं है, क्योंकि वो भी अंदर डाल सकते हैं. अभी क्या करेंगे?
Who lives with the family?
मैं फैमिली के साथ नहीं, मेरा जो बाहर रहता है वो बच्चे का साउंड आ रहा है ना.
हाँ. तेरी फैमिली है वो.
वो जो गार्ड है उसका दोनों बच्चे दिन रात.
Okay. We have the array. What else?
लेंथ
Length
और स्टार्ट एंड भी कर सकते हैं.
और
लेंथ ही कर सकते हैं. लेंथ स्टार्ट एंड तो लेंथ से ही पकड़ सकते हैं. बट स्टार्ट एंड से फायदा होगा. एक लूप करेंगे अभी इक्वल टू 0.
okay. Recursion. At least recursion. Tell me recursion. So if not recursion, then at least tell me the basic solution, which is using recursion. It's not a straightforward recursion because most of the recursion looks straightforward to you because you can easily find your sub problems. You can easily find your sub problems. But यहाँ पे सब प्रॉब्लम ढूंढने में ही थोड़ी कठिनाई हो रही है.
पीछे वाला किसी से मैच नहीं हो रहा है. सबसे बढ़िया तो ये है. पीछे वाला कोई प्रॉब्लम से मैच नहीं हो रहा है.
You only Athar only Ashna, that's why.
I think simple solution will be we have to keep the index and we have to keep checking the value also. So let's say we start with 0 and 0th index, that is 1. So 1 से we know that 1 is the value. So basically वो index की value तक जाएंगे हम लोग basically for loop में. So that will be, we will jump from 1 to 3.
Yes.
That is 1th index. So now from 1th to the value of that index, that is 3. So हम लोग 3 jump मारेंगे, that we will reach to 9. And after 9 we will like उसी का 9 हम jump मारेंगे, तो that will be the end of array itself. So that's
Okay, so let me just say what you were saying, and then at least now you should be able to write the recursion. So we are starting from beginning. We start from beginning 0. Okay, and then what are the options? We can go to only with this step only. Let's come to this step. And what are the options? Now one option is 5, one option is 8, one option is 9. We can go to any of them, and either of jump can be the best. I don't know which one. So we'll have to try for all of them. So recursion will be something like the way to reach your 9, the way to reach a 9 from 3 will be equal to
0 to a of I.
No, yeah. So number of ways to reach 9 from some index before that will be equal to ways to reach all the other places which can be reached from this index. So I'll write something. So number of ways to reach from I to j, I to end. Okay, there are, what we want to find is 0 to end. 0 to end. We want to find this at the end. But forget about that. So number of ways to reach from I to end will be equal to number of minimum number of jumps to reach from I to end will be equal to one jump plus all the possible jumps we can make from it, all possible jumps from that index, possible jumps from that index I. So यहाँ तक पहुंच गए, इसके बाद एक जंप तो लेना ही लेना है, तो वो एक जंप लूंगा मैं, वो कौन सा लेना है वो नहीं पता, बट जितने पॉसिबल सब सारे ले लो, जो भी उसमें जो मिनिमम वाला होगा वो आंसर होगा. Is this
right?
Clear?
Yes, minimum all possible. Okay, 5, 8, 9 on minimum. Correct?
Yes. So I तक पहुंच गए अपन. Now I से end पे पहुंचना है. So all the possible jumps which can make from I is we know that depends on the current value. So whatever. So all the possible jumps we can make from that index, and take the minimum of that. Whichever is the minimum will be my answer. है ना?
So इसमें 9 आएगा, right? Because 9 से आगे jump कम है compared to 8 से.
So from 3 we can jump to 5, 8 and 9.
Right.
Any one of them. And I try with jumping with 5 पे jump करके क्या total मिलेगा I don't know, but it will give me answer. It will give me answer 2, 8 से किया answer आया 1, 9 से किया answer आया 1. So either of them will minimum of this, minimum of 2, minimum of 1 and 1. So we can take this one. So all possible jumps are minimum of all possible jump from I. What are these? So अगर 5 पे गया तो 2 jump लगेगा, 8 पे गया तो 1 jump लगेगा, 9 पे गया तो 1 jump लगेगा. So minimum of these 3 are just 1. So 1%. And which one we are choosing? That anyone we can, not a problem. We can choose anyone. Either 8 wala or 9 wala, both are same only. So at the end this is 2. So 3 से 9 पहुंचने में 2 jump लगेगा minimum. पहला जंप कहाँ पे लेंगे? पहला जंप 8 पे लेंगे या 9 पे लेंगे? Let's make it complex for you. Let's make it this 3. So now there are 3 options, whether 5 पे जाएं, 8 पे जाएं, 4 पे जाएं. So I don't know which किसमें फायदा होगा, but I think we should try for all of them. So I tried for 2, 5 पे किए 2 स्टेप लगा, 8 पे किए तो एक ही जंप में पहुंच गए, और 4 पे गए, नेक्स्ट वाले 4 पे गए तो हमें 1, 2, 3, 4 2 जंप लगा. So in this case it will be minimum of 2 and 2 and answer will be 1 and 2. ठीक है? Correct?
Yes.
So what we have to find is we have to find 0 to end, and for that we go from bottom up and whatever we do it for all the position after that. Now what are those positions we have to try? That is the dynamic, that is something like a little bit complex, but you have to call this recursion multiple times while going bottom to up. Not just 2 recursion or 3, there can be multiple, because we don't know what is the number of possible ways. So अभी तो जो वैसा ही है ये भी. The only difference is we don't know the sub problems. So another good difference is till now every time sub problem was like decreasing. So I से j जाना है, I से n जाना. This is the main problem, ठीक है? Now अभी तक क्या होता था, हमेशा सब प्रॉब्लम तो I माइनस करते थे और n माइनस समथिंग that वो करते थे. इसमें थोड़ा सा अलग ये है कि हम लोग I इंक्रीमेंट कर sub problem होगा हमारा. I plus something will be a sub problem, and for problem I n, the sub problem is I plus something n. This is a sub problem. है ना, ये सब प्रॉब्लम है। आई एंड के लिए सब प्रॉब्लम क्या है, आई प्लस समथिंग एल्स, दिस इज अ सब प्रॉब्लम, दिस इज अ मेन प्रॉब्लम एंड द सब प्रॉब्लम आई प्लस समथिंग एंड नॉट माइनस। अभी तक जो हम करते थे सब माइनस माइनस सब प्रॉब्लम हुआ करता था, बट इट्स इंक्रीमेंट आई, obviously size is decreasing but index is increasing, this is a sub problem. समझ में आया डिफरेंस? Difference समझ में आया? There are two difference. One is the sub problem is like we are doing is kind of adding to the input. Not my input size is decreasing for sure. Input size हमेशा ही घटेगा घटेगा. Sub problem का input size will always go. Indexes might increase decrease whatever. Like this is not confuse you. Just to let you know. हमेशा ऐसे मत सोचना कि I minus का फायदा होगा, n minus फायदा होगा. There might be हम indexes change करें in a positive way. Obviously sub problem will be a smaller sub problem, size to घटेगा problem का, but ठीक है, that's one thing. Second difference was there are I'm not this number of sub problem is not fixed. अभी तक जिस तरह से number of sub हमेशा दो sub problem तीन sub problem, इसमें number of sub problem also has varied कि that depends on the value at each sub problem we're talking about. So 3 पे हैं तो तीन sub problem है, और अगर 8 पे हैं, अगर 8 पे होते हैं, 8 पे होता है suppose it was a long ऐसा कुछ होता, और हम 8 पे होते हैं तो हमें फिर हमारे पास 8 सब प्रॉब्लम होते हैं कि कहाँ पे जाएं
8 में से फिर एक मिनिमम निकालना पड़ेगा।
तो that would have been 8 sub problems. So our sub problem is not fixed, it typically varies every time, but इतना vary नहीं करेंगे, we can code for this, but yeah, go ahead and write this now.
Basically it will vary on the
Yes.
number or number of that, like
Yes.
8 है तो 8 पे vary करेगा, right?
Yes. So we have to solve for all the sub problems, all the 8 sub problems. Then we jump ahead, we'll solve for all the x sub problems. So we have to.
So basically we can write two loops.
Yes.
एक सिर्फ loop through like एक जाएगा for each and every element के लिए, और within that loop we can have another loop which will be just for zeroth, like that index till जो कोई index का number है, let's say 8 है तो 8 तक basically.
Yes, you are all exactly correct. बिल्कुल सही है. So this is that you have directly given a DP approach without even thinking about the recursion, which is okay, which is nice. Because why? So it's not necessarily हमेशा recursion करके ही solve करेंगे, because there are times we don't even consider recursion. So you're right. Just try to write that code now. आपको समझ में आ गया तो अच्छी बात है. Write the code. Otherwise think about the solution. मैंने काफी बता दिया है. So whatever just Asal said is correct. I'll be back in 2 minutes.
अच्छा पूरा डीपी सॉल्यूशन बता दिया क्या? पूरा डीपी सॉल्यूशन बता दिया.
वो आंसर ही तो बता दिया था उन्होंने. समझ, वो ऑलमोस्ट वही था. So
I end or I plus one end.
Yes, I'm back. Any solution?
मिनिमम ऑफ कुछ तो भी होगा अभी. मिनिमम ऑफ मिनिमम के अंदर ही अभी रिकर्शन रहेगा, राइट? मिनिमम जंप ऑफ एवरी एलिमेंट बेसिकली फॉर दैट अरे.
Yes, right. You're doing right.
Praveen, I have written one recursive solution on WhatsApp.
Okay. And that is a screenshot, not even a text.
No. I've written text.
Okay, nice. You have typed on the phone with this indexing on?
No. I have laptop as well.
So current minimum jump from current to max jump will be equal to current dot up to what is jump? ठीक है?
Which one? Sorry, that is max jump. Sorry.
Is max jump?
Yeah.
Output plus is equal to minimum jump from array of E to array of plus array of E. Can you explain? I'm not understanding this. Achal,
Yes.
your solution was on the right path. Complete that. Nitesh?
Yeah, but I'm not able to understand like minimum element जो अभी लेंगे वो कैसे लेंगे like for that array.
Praveen, can you scroll up?
Okay.
Praveen, can you scroll up?
Yes, just again.
Hmm.
Not, does it give some idea? Whatever written. Yes. This is what you wanted.
Yeah.
Sleep?
Yeah.
Okay. So, sir, you were stuck there. कि कौन से लेंगे? So you had so many. You had how many options from I to area of I?
Yes.
J equal to I to less than I plus j area of I. है ठीक है?
Okay.
So for all these j's, for all j's, you want to find out which one is the optimum. So you
Yes.
maintain the optimum. By optimum we mean
Yeah,
minimum.
we have to maintain, like we have to store somewhere minimum jumps, right?
Yes, because there was no static subproblem, we have to maintain for all the subproblems. All subproblems are different j's. So for all the j's, you have already in this loop. So what to do? So calculate from j to end. So I could from the to end, and then new minimum jumps is equal to this, and then you simply do your one logic. If this new jump is
Less than, तो new jump ये हो जाएगा, right?
ठीक है?
ये calculate कैसे करेंगे बट J से?
Yes, that's what I'm doing. I'm also thinking now. Let me.
Yeah.
Is this correct?
Minimum jump.
Recursive calling.
Jump.
This is a recursion. Right. So we have to just improve that to make it a DP.
But why do we need end here? We don't have to go through each and every element till end. Rather, we have to go till array of I only. क्योंकि this is inside that second for loop, right?
Just a second.
So let's say 3 है, तो 3 number तक ही jump करेगा, right? We don't have to go till end of the array.
Yes, just a second. So I think this inner loop is what we need. And this is start to end. This main problem. Minimum jump from start to end will depend on so for j equal to start से लेके j of start plus array of start array I करता हूँ क्या I करता हूँ I means start. Okay, so from j equal to start to I plus array I j plus new minimum equal to minimum this. Does this make sense? And at the end, what we just return is return minimum jumps. One more thing is here, minimum jumps is equal to some integer of max. So we have to, and we start this call from 0 to I, 0 to last, and we. Is it clear a little bit? क्या कर रहे हैं हम? So we want to reach from start to end. Start is I and end is end, whatever. So for us to do this, so that we want to calculate this thing at the end. 0 to end पहुंचने क्या चाहिए? So to 0 to end पहुंचने के लिए, what we do is we just I to end पहुंचने के लिए we just check for all the possible options from I. All the possible from option I is I plus 1, I plus 2, I plus 3 till I plus array height. सारे possible options है. So we try to calculate minimum jumps recursively for all those possible options, and we were just while doing that, just maintain them with whichever gave the minimum, and just return that plus 1. ठीक है?
I का इंक्रीमेंट हो रहा है और
I increment नहीं हो रहा. I is what we want to find, but वो I increment हो रहा है in this recursive call. हमें start किया 0 से find करना. That 0 has been used. यहाँ पे I plus 1, I plus 2, I plus 3, I plus n, I plus array I सारे call हो गए हैं. यहाँ I increment हो रहा है इस recursive call में. So there are if I try to write this in again older way, what you want to return is return minimum of min jumps of this array with I plus 1 and same n, comma I plus 2, comma I plus 3, ऐसे करते करते I plus array of I तक जाना है. Minimum of all those numbers. यही अभी तक तो ये करते हैं हम लोग. बस ये इसके लिए हम लोग जो ये कोड लिखना है. यही है ना, इसी को मैंने फॉर लूप में लिखा है. अब तक ये दो फिक्स हुआ करते, दो ही होते थे, +1 +2 -1 -2 होते थे. यहाँ पे वेरिएबल है तो वो वेरिएबल को हमने हैंडल किया है. दिस इज द वे टू हैंडल द वेरिएबल थिंग, एंड देन वी डूइंग सेम थिंग. इज दिस करेक्ट?
I plus sum comma end correct वही
I plus
sum SOME जो पहले लिखे थे.
not audible, can you speak louder?
I plus sum.
I plus sum. What is sum?
Can you scroll up? ये
This sum?
हाँ हाँ
हाँ तो I plus sum वही तो ये sum है. What
वही बोल रहा हूँ.
I plus something. So what is something? That's 1, 2, 3. Then all are something only. All these possible options. ठीक है? कुछ confusion इस solution में? This is a recursive solution. What is the time complexity of this recursive solution? What is the time complexity of this recursive solution?
mn.
Not
I j है ना अभी इसमें I से for every I element to traverse.
So length of the array.
Yes.
Length of the array.
And length of that index also.
To the power something. What is something?
Minimum of I or j. So
it will be exponential and it will be n to the power something, and that something will be maximum value in this array, because वो decide करेगा हम हर बार कितना सब problem break करें. So the number of this is like very
yes maximum.
The number of sub problem decides की power कितना होगा. Sorry, no. This will not be n to the power. This will be every time we are taking so many sub problems. So that x to the power n.
Right.
And x is the number of subproblem maximum we can see. And what is that? That can vary, but we'll take an average. We'll take the maximum worst case. जो जहाँ पे भी सबसे ज़्यादा subproblem हो सकता है वही वाला होगा. The maximum of this in this array is suppose 28. So then it will be 28 to the power n. ठीक है, but ठीक है. Maximum value where x is the maximum value in the array. Where x is the max value in the worst case लिख रहे हैं ना तो चलता है. And in the array, where x is the maximum value in the array. Why? Because that is the maximum subproblem we can break ever. ठीक है, समझ आ गया?
Yes.
नितेश.
Yes. I'm putting my solution as well. It's like.
So this is a recursion, bad recursion. चलो जल्दी से improve करना है इसको अब for a good DP with a good DP.
आई थिंक यही डीपी वाला सॉल्यूशन था.
इसमें storage the storage
Yes.
size is a problem, right? Because we don't know the maximum limit of the jump. We know the input array, but what will be the maximum jump?
What do you want to store? You want to store something which you don't want to calculate again. So what is that
Correct.
getting? So this what is
J and
changing?
end.
End is not changing. End terms वही का वही है.
अच्छा.
अगर हमें end तक पहुंचना है, तो end तो वही. So what's changing is J. So this is
J.
simpler storage. This is much simpler than your two dimensional. This is single dimensional storage. कि हमें जब भी I want to calculate for some other value, I want to just see कि उसके other J's में क्या क्या stored है पहले से. मतलब to calculate for I want to know for all my I plus 1, I plus 2, I plus 3, I plus n, and I don't want to calculate this so many times.
Again.
Yeah. So storage is simpler, just 1D storage. So, and what is storage? Storage, two things. One is the actual answer. It contains the actual answer for all J's. So storage will be something like the storage will be a 1D array of size n is a size of array. So and the size of the array. So what will storage of I contain? At the end, what will storage of I contain? This will contain the minimum number of jumps to reach from I to n. This is what it means. Minimum number of jumps to reach end from I. ये मतलब इसमें at the end what I want to return is storage of what? Storage of what do you want to return at the end? कोई बताएगा?
Last one.
0. Minimum number of jumps to reach end from I. So we calculate for number of ways to reach from 0 to I2. For that we need values. Already calculated value we need is for bigger values. So ये तो top down आ रहा है तो and say just wait. I'm thinking. So we have to reach end and we want to reach from 0. So 0 calculate करने के लिए हमें सारे बड़े values calculate करने होंगे. Okay. How do we do that? So reach from अगर top down ही करें तो okay. So I'm changing a little bit. We have the storage, but storage of I means something else. This is minimum number of jump to reach I index. And what do you want to return at the end? What do you want? We want to return storage of n. Something like this. Now we have to work on the solution. Can you do this way? Think if you are not able to think. First, do you understand what I'm storing? My story about my problem. So this was the recursive solution. And I'm not trying to come in DP. The first thing is storage. I have initialized my storage with what does every cell means. minimum number of jumps to reach I index, and hence what you want to calculate is minimum number of jumps to reach the end. With this logic and with this recursion, can you calculate now? But try to take a bottom up approach. Try to go for all the we want to reach n. So let's try to calculate for all the smaller values first, and then try to go ahead, keep on going ahead. Because your recursion needs smaller values, so you have to use smaller values. All the smaller values has to be calculated before you try to calculate for end. All the smaller values has to be calculated so that you don't have to call recursively again. So yes, try to think again with a bottom up approach. It might not be as similar as what we have written for recursion. So try to think about the other solution, like normal solution of a bottom up. What will you do? What does bottom up means? सबसे छोटा value के लिए क्या कर लेंगे, फिर उससे बड़ा value के लिए करेंगे. So while doing that, you might have to do some recursive call, but try to write the bottom up approach. Try to calculate for all smaller sub problems. Start from a problem 0, then do for problem 1, do it for problem 2, and then try to reach n. Enough of hints right now. Subhadeep,
हाँ
समझ में आया क्या करना है? Can you do now?
कोशिश कर.
हाँ, try. Okay, this will be the last question आज के लिए. Okay, so we have a solution from Ritesh. Ritesh.
Dennis Halak.
Okay, so you have to write this. Take this as assignment. I have one more assignment for you, which we discussed earlier. Coin change problem. Whoever is awake will try to complete this now and send me. We don't be doing any more questions after this. The coin change problem with only one denomination, one of each denomination. Unlimited supply नहीं है, ठीक है? This is the second assignment. First assignment what you are doing right now. ये वाला करके submit करो अभी WhatsApp पे. I'm going to stop this class now, and then you have to submit this code, whatever you're writing. Try to finish this. Don't try to ignore this. Okay? और second वाला जो हमने किया वही है, but with her. Okay, something there. I have two solutions. One is from Nitesh, which is I haven't understood. Now the second is from Subhadeep. He says, okay, store I equal to max. Store of I equal to max. What is max? I don't know. What is max?
Int max.
Okay. Yes, change less than equal to array. For every I, you do go to j and then you try to zero j. So j is less than I of L plus array of I. Store I into store j. Store I into store I equal to store j. कोई मिन नहीं है कुछ नहीं है. Why do you think it will work? कहीं पे मिनिमम निकाला भी नहीं है. I don't know what you're doing here. I don't know what you're doing here, but there is nowhere min. Huh?
I'll think.
Yeah. Okay. Athar, if you want, you can also solve, or you can go to sleep, whatever you want. But there are two assignments, and there was one assignment previous class. What was that? We discussed in the initial beginning only. Anyways, we discussed in the beginning that which was submitted by Subhadeep. Okay, no, not much assignment. But after this assignment, we will now switch to some other topic. We have covered array, we have covered strings, we have covered linked list, double linked list, and all those. And then we have done this dynamic programming separately, which is algorithm, not a data structure. But among tree also we have covered a lot. We have not seen the spatial trees, AVL and red black exactly. But AVL we did in a question called height balance. That was AVL tree only. Red black हमने नहीं किया है. Do you want me to cover that, or do you want to skip that? What do you think? From me, do you want to cover or not red black tree?
Better we can cover more questions on binary tree.
Binary tree only. Nice. ठीक है. So others, what do you think? Do you want to cover? Okay, but I'll do just give you a flavor of what red black tree is, so that if someone asks you also, you should be aware of what that red black tree is and what is the user of that. Okay, we won't do much questions on that because there won't be many questions only.
I think
So,
for red black, they usually ask to insert or delete. How to insert and how to delete.
yes. So that's what we'll do. Okay, so how to insert and delete. Okay, and then what other data structures left apart from graph? What else is remaining? So yeah, we'll do a lot of graph now. We'll start theory of graphs. Graphs has a lot of theory, but parallelly it has lots of questions as well. So we'll start graph from tomorrow class, then Monday.
Okay.
Okay.
A heap and hash.
What hash? There is no special theory about hash map. This is just used somewhere. I don't have any special theory for teaching you hash and hash map. That's like teaching you Java ka how does the hash work? How does the hash is equal to implemented? How the hash ka indexing implemented? I'll talk about a little bit. I think I have talked about this. कि collision कैसे remove करते? What can be a very good hash mapping function so that you avoid collision? So what can be simple ways are mod. We take mod of the value, and then we generate our key where to store that value. So that hash map, how to find a better hash map function, that is a theory only there, but I don't see it getting used anywhere in the interview. So I'll just do 5 and 10 minutes of hash.
So one more question, Praveen. You said in the first class that we will do that heap structure and insertion deletion. So the question is do like interview में ऐसा कुछ सवाल पूछते हैं on particularly on heap, or we can directly use a library or something like STL library in C++. ऐसा कुछ.
The first question I had given, in that I would not expect you to implement heap. I would just say, okay, you can do a heap mean
Right.
heap. But then if they actually ask you, can while giving this solution, they will tell you, okay, what do you mean by heapify? Can you implement your heapify? So you should know the meaning of heapify, and you should be able to write the code for heapify. And we will cover that. We have missed that. We will cover the heaps. How to implement a heap, how to do heapify, how to insert heap. That is also a point which we haven't covered. We have to cover that also. Heap and graph. Anything else?
Algorithm में और कुछ रहा like backtracking फिर से करना है नहीं करना है वो
एक बार कर लेंगे.
Okay, backtracking dynamic greedy हाँ. मुझे पता नहीं.
Yeah, all these standard algorithm we'll do once we are done with our all the data structures. So I think we are left with heap and graph, and then I don't remember we have done the stack, we have done queues, we have linked list, double linked list, everything we have done. So only what thing remains is these two only. So we'll cover this and then we'll go for other algorithms. And thing is, while solving these problems, only we end up solving those algorithms. So but still, अभी हमारे पास काफी classes हैं. We'll cover some algorithm. We'll take 2 classes max for our graph and heap combined. Heap will be half class and graph will be 1.5 class, so 2 classes more. And then we'll do questions plus we'll start with other standard algorithms which we should be aware of for an interview. They might have been used earlier only, but yeah, we should be aware of with their name also a little bit.
And let's keep at least last three classes just for questions.
हाँ ठीक है, so we'll do that.
हाँ, like जिसको जो टॉपिक में कोई क्वेश्चंस करवाना होगा तो वैसे कर सकते हैं.
Complete mix so that no one is aware कि क्या कौन सा टॉपिक से बात हो रही है. That kind of classes is very much required.
Mix. Yeah.
No pre-knowledge of what topic we are talking about. 3 classes should be good enough for that. Yes.
Okay.
Okay then. Try to submit the assignment whenever you want and as soon as possible also. But
ये वाला
we'll
और
be
coin
yes.
change. ये वाला और coin change.
ये वाला और हाँ yes.
And can you please upload like both the videos today and
अभी पहला वाला तो अभी तुरंत हो जाएगा. आज वाला एक बना.
Okay, sure. Yeah.
And tomorrow same time 10:30.
10:30 morning.
नहीं, night.
Oh, Monday, right?
Morning to 8 o'clock. Which one you prefer?
Yeah.
Which one you prefer, Subhadeep?
10:30.
ठीक है. Okay then, bye bye.
Yeah. Bye.